Okay, so 7.1 is dilations, and a dilation is a transformation that can change the size of a polygon but leaves the shape unchanged. A dilation has a center of rotation, of dilation, and a scale factor, which determine the position and size of the image. The center of dilation is the fixed point about which all others are transformed. The ratio of the lengths of the corresponding sides is the scale factor. And we call the scale factor K. So are the following dilations? Well, if we check all the side lengths on this, 1, 2, 3, 4, and this one's 4. This is 4, and this is 4. This one is 2, 3, and this one is 2, 3. I believe so is this one. So technically, all these are the same size, aren't they? But we could actually say, yes, it's a dilation with a scale factor of 1. I know that's weird, but some books do that. I say no, I don't think it's dilation. So let's check this one. So here we have 1, 2, 3, 4, 5, 6. 1, 2. And this is 1, 2, 3, 1. So that's a scale factor of 2 for that one side. Let's check. I meant to do this in pink too. Let's check another side. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. And this is 1, 2, 3, 4. And this is 1, 2. Again, that's a scale factor of 2. Each of these are being multiplied by 2 to get the bigger figure. So let's check this last one. 1, 2, 1, 2, 3, 4, 5, 6, and 1, 3. So yes, this is with a scale factor of 2. It got bigger, so it's 2, not 1/2. You got to be careful of that too. Is this a dilation? I'm going to pause this and check all these and then come back to make this not so long. So if we look at all of these, every one of these, if I look at 2 over 3, 2 over 3, 2 over 3. Here's a different one, so we need to see 3 over 4.5, 2 over 3, 2 over 3, 2 over 3, 3 over 4.5. So we just need to check that. And if you put this in your calculator, 3 divided by 4.5, you get 2/3. So yes, this is a scale factor. It got bigger though, so instead of 2/3, the way I wrote the scale factor is actually 3/2. All right, and then this one, well, this remained the same length, but this one, this side is only 3 and this one's 4. So this is no, it is not a dilation. All right, so the notation D sub 3 means that we're dilating it of a scale factor 3 about the origin, okay? And as long as it doesn't have another something here like point P or whatever it happens to be dilating about, it's about the origin. So the easiest way to do these is to write down your points. A is at 2, -1. B is at -1, 2, and C is at 3, 0. And then we're going to multiply them by 3. We're going to multiply both of them. So A prime is going to equal 6, -3. B prime will equal -3, 6. And C prime will equal 9, 0. After you draw that figure, you can see it looks like that, and it's 3, a multiple of 3 bigger. And we can check that. So if I look at this, I got 1 by 1. Well, this one's going to be 1, 2, 3, 1, 2, 3. So that side is 3 times larger. And then we're going to go down and do this one. What are the vertices? And see, this is a dilation of 1/4. So again, we're going to write down our points. PQR. P is at 8, 4. Q is at 12, -4. And R is at -4, 0. And I'm going to multiply these guys by 1/4, which is like dividing by 4. And I get D prime is at 2, 1. Q prime, well, not D prime, P prime. Q prime is at 3, -1. And R prime is at -1, 0. And if I plot those, P, Q, and R, you can see it's 1/3 smaller. 1/4 smaller. And how are the distances to the origin from each point related to the distance? Well, it's reduced by 1/4. All right, on this next page, it talks about drawing stuff. I need you to notice this. This is the center of rotation, so it's not the origin anymore. We would say dilate by 1/2 around P triangle ABC. That's how that would look. But I want you to notice, if I draw a segment from B to P, I get a distance, I'm going to just guess 2 inches, let's say. And then if I do the same thing from P to B prime, I get 1. So I can see that it is reduced by 1. And that will work. I don't care what the distances are. They will be half of that distance. So if we look here, it says, how are the side lengths and angle measures related? Well, first off, the angles are congruent. Angle size does not change. This is 3 and this is 1. So there's a scale factor. It is getting smaller, so 1/3. So this next one says, is the dilation an enlargement or reduction? Well, it's getting smaller. It's reduction. And the scale factor is 1/2. This is 2, this is 1. That's enough to show it, but we could say 1, 2, 3, 4, and the side's 2. So I can see it goes down 1/2. All right, determining the center and scale of a dilation. So all you do, and it's really hard for me to do this on here, but you're going to draw a line segment with a ruler between A and A prime. Then you're going to draw a segment between B and B prime. I missed it. And then you're going to draw a segment between C and C prime. Oh, that worked out good. Right here is your center of dilation. Same here. I'm going to draw a segment through A prime, C prime, and then B prime. And where they meet is the center of dilation. So this just wants to know if the scale factor is equal to 1/2. Well, the first thing I'm going to see is that the shape gets bigger. So it can't be 1/2. It's got to be 2. All right, now here, this is a lot of stuff here, but we are just going to do it on this one little graph. So it wants to dilate it around R. So what we're going to do is by 1/2. So each point is half the distance from R as the corresponding pre-image is. So S is 1, 2, 3, 4, 5, 6 away. S prime is going to be 3 away. 1, 2, 3. And there's my S prime. Q is 1, 2, 3, 4, 5, 6, 7, 8 away. And so Q prime is going to be 4. 1, 2, 3, 4. And there's my Q prime. And then T would be both of them away. 3 one way, 4 the other. And that's where it would be then. And R prime, of course, would be right where it is. And that's all this box is saying. And then we didn't use this graph. Okay, what is the center of dilation? Well, here I can see that A and A prime are in the same spot. They didn't move. If I drew a line through it, that's where they'd meet, right? B prime, A prime, C prime. So the center of dilation is A. Now this shape is getting bigger, okay? And I'm going to check one side. Let's check this side. So it's 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6. So not 6 over 4. I mean, not 4 over 6, but 6 over 4, which is 3/2. And if I did this 1, 2, 3, 4, you see these scale factors are 6 over 4. All right, and that is a crazy picture. And that's all there is. The rest is your homework.